there's no amount of vitamin C, there's no amount of zinc, there's no amount of elderberry that can overcome immune dysregulation from a dysfunctional microbiome, right? So you can take all of those and they're great for your immune system, but the underlying function of your immune system lies within your microbiome. Now, why does fiber matter so much? Well, number one, because high diversity in your gut microbiome is directly associated with longevity and disease resilience, right? Right. And then fiber also acts like what these GLP-1 drugs are doing. They're slowing down the metabolic the digestion process. They're increasing satiety signals so you don't overeat. What people don't usually know is that contraction of your muscles against a force like a weight actually releases a set of chemicals called myokines that can actually go and heal and improve your gut and increase the gut microbiome diversity. One of the things I've always said, for example, is when my kids were of that age where they were eating their boogers, I let them eat their boogers, right? Yeah, boogers are like these amazing little vaccines that people are self-vaccinating with.
So, Kiran, thank you for your time and thank you for being with us. Just by means of introduction, Kiran's an advisor to Daily Nori and also someone who I've personally learned so much from on my journey of not only building Daily Nori, but just understanding more about the gut microbiome. So thank you, and thank you for your time here. I know it is precious. And so why don't we just start with you introducing yourself, and then we'll go from there.
Yeah, well, thank you for having me. It's a pleasure to be here. I always love any opportunity where we get to talk about the microbiome and health and wellness. I think, empowering people with knowledge like this is a really important service. So to give people a background, my training is as a research microbiologist, and I got into the world of the microbiome specifically and how it relates to health and what you can do about it about now almost 20 years ago. I've developed some products. I built a company called Microbiome Labs, which kind of became the preeminent microbiome therapeutics company for healthcare practitioners. I've since sold that business and developed other technologies and products, and have had the pleasure of doing lots of research in this space, publishing a lot of clinical trials, and then working with amazing, passionate founders like yourself.
And one thing you've done so well, and this is one of the reasons why I think I've personally learned so much from you, but I would just say probably millions of people now with all of the content and all the conversations like this that you've produced and been a part of, you've bridged this translational gap. Is that how you say it?
Mhm.
I think
Yeah.
this is really important. So what do you mean by that when you say that?
Yeah, that's where I found my purpose, right? So I was initially, based on my training and education, I was going into academics and into academic research as a career. So eventually becoming a professor and running an academic lab. But there is a translational gap that occurs. So what that means is that there's a lot of research that's happening in the world of professional research, right? Which is within universities, institutions, and so on, but rarely does that research translate into something that impacts humans. And that is called a translational gap. And the reason for that is because a lot of that research is not being done necessarily with a goal of a product or a service or a test in mind, right? It's being done for research sake. Like a great study opens up more questions than it in fact answered, and that becomes kind of the basis of the next grant, of the next institutional money that comes in. And that's all really important. I mean, we learn a lot from that kind of research, but it also requires people and companies to bridge that translational gap, to take what's being learned here and translate it into technologies, understanding, behaviors, therapeutics, and so on, for people to effectively change their lives. And I found that where my talent lies is understanding the research at that level, and then being able to visualize and see the opportunity for what that research is showing us to construct things that can actually impact people's lives. And the microbiome is such an amazing area for that, because even in the last about 5 or 6 years, there have probably been about 60 or 70,000 research papers produced related to the microbiome, right?
Yeah.
It's crazy. It's the
Yeah.
biggest research revolution there has been since the dawn of recorded research.
Remembering kind of one of the areas that this struck a chord with me, which is a good place to kind of start topically, is the immune system. So, how does the gut and the immune system, how are these two systems so intertwined?
Yeah, that's a really important question because it not only bleeds into the area of defense, right? Defending the body against potential invaders like viruses, bacteria, and so on, but it also goes to the tolerance side of things, which is, one of the things I've always say is you don't want an immune system that underreacts, but you certainly don't want an immune system that overreacts, right? Where it's attacking things it shouldn't attack, including food particles, environmental particles, your own tissue, and so on. So how does that balance? How is that balance struck? And then where does the immune system get its instructions from? So this is where the microbiome connection comes in. Now, most people have heard the saying that, 75, 80% of your immune system's in your gut. They don't really understand what that means. Well, what that actually means is that 75 to 80% of the immune sampling tissue is in your gut, right? So what is immune sampling? Immune sampling is the process by which the immune system measures and detects what is within your environment, right? So keep in mind that the immune system has to adapt to the changing environment, right? It's one of the few systems in the body that has to adapt on a day-to-day basis almost. If you, Caroline, you went from New York, East Coast, and you flew to LA, you're going to have different antigens, different things you're exposed to. And in that short amount of time, your immune system has to realize what those different things are and then adapt to dealing with it. And the adaptation is A, does it upregulate immune defenses against a potentially harmful thing? And or B, does it recognize the new things you're being exposed to as not harmful so it tolerates it? Right? What you don't want to happen is you don't want to go from New York to LA and then all of a sudden all the pollen and things like that are in LA start creating havoc in your system, right? You want your immune system to recognize that, hey, that's not harmful. I don't need to attack that. So this translation and this intelligence comes from the immune sampling tissue that lines your gut. Virtually everything in your environment, one way or the other, ends up in your gut. Even things that go through your eyes, your ears, and your nose, they drain into the back of your throat and then you swallow it, right? Things that end up in your lungs, your mucus system grabs it, and then your mucociliary elevator, this is like all these hair-like structures, moves it up from your lungs into your digestive tract. So almost everything around you ends up in your digestive tract. It hits that immune sampling tissue. Your immune system looks at it and goes, okay, what is this thing, right? Do I need to pay attention to it? And it gets the cues from your microbiome where the microbiome says, hey, this is pollen. You don't have to deal with this. Just tolerate it. Or, oh my God, this is a new virus. You have to deal with that. And so it can flag it for action. Your immune system is not born with that innate information, right? Your immune system is born naive. So your immune cells that are born in your bone marrow or in your thymus gland, they come out. They're like soldiers without any training. They have all the weapons and capabilities. They have tanks and bombs and everything else, but they have no training. They don't know who the enemy is. And the general that they follow is the microbiome. You're dependent on a healthy microbiome to instruct the immune system as to who to attack and who not to attack, who is friend and who is foe. This is why you brought up COVID, which is a really good example. This is why comorbidities, right? So people heard this term of comorbidities. There were certain categories of people that had a far worse outcome to COVID than other individuals. And in fact, lots of studies that were done at University College Cork, they were able to sample people's microbiome and predict whether that individual, when exposed to COVID, would be hospitalized and or die from it. And they were super accurate in their prediction just by looking at their microbiome. So what they found is that if your microbiome is dysfunctional, meaning you have too many pathogens or dysfunctional bacteria or inflammatory bacteria, those microbes will not help your immune system detect the presence of a new virus because they themselves don't want to be detected. So they actually shut out the immune system rather than recruit the immune system. The beneficial bacteria will recruit the immune system when a new virus or bacteria comes in, and at the same time upregulate the immune response, training the immune system that, hey, this is a problem, you need to deal with it, right? So people who are diabetic, who are obese, who had history of heart disease, all of these conditions are associated with a dysfunctional microbiome, and they had 8 to 10 times higher risk of mortality and infection. There's no amount of vitamin C, there's no amount of zinc, there's no amount of elderberry that can overcome immune dysregulation from a dysfunctional microbiome, right? So you can take all of those and they're great for your immune system, but the underlying function of your immune system lies within your microbiome. So you have to think about that first.
The other thing that we've seen that it kind of is also immune related, I wanted to ask you about is autoimmune diseases, because we've
Mhm.
seen these also like Hashimoto's and all of these issues are just, again, more and more prevalent. When you're thinking about the immune system and then thinking about a little bit deeper here and a little bit more serious, right, as these autoimmune disorders, what's going on with those?
Yeah. So this is a part of the immune cascade, right? So here's generally what how the immune system responds when something new comes in or something that you've seen before. Typically, the innate immune system responds first. So these are the fast first responders to the problem. These are cells like your dendritic cells, your natural killer cells, and so on, right? But the problem with these cells is they're fast to react, but they don't know what the culprit is. They don't actually have a way of understanding who specifically is causing the problem, but they know where the problem is, right? So they rush to the area and then they blowtorch the whole area. So their form of function is like, I'm just going to get there. I know there's a problem in this area, and I'm just going to bombard that area with inflammation and things that'll kill cells until the adaptive immune system can show up. That's the part of the immune system that has long-term memory and intelligence. When it shows up, it can identify what the actual culprit is, and then it produces antibodies against just that culprit. So it doesn't damage anything else. Now, because it's all debris, this antigen presenting cells can accidentally grab your own proteins, your own tissue, because you've got your cellular debris in that area as well, and then present that to the adaptive immune system, and then the adaptive immune system may see your own proteins and go, aha, that's the culprit, and develop machinery against your own protein. That means anywhere in your body that protein is present, it'll get attacked. Right now, to prevent that from happening, there's a component of your immune system called T regulatory cells. These cells see that accidental presentation and go, nope, that's not the right thing. That's our own protein. Don't present that, right? So it shuts it down and it reduces the risk of accidental presentation of your own protein. The thing is that T regulatory cells, their function and their upregulation is dependent on a healthy microbiome. So when your microbiome is unhealthy and you've got lots of inflammation, lots of things that your immune system is attacking, then you have a higher risk of your immune system accidentally presenting your own proteins as the culprit. And then anytime your immune system sees that protein, it'll attack it.
So one of the, I mean, big causes of, underlying, I would say, destruction, microbiome destruction, has been this overuse of antibiotics. One of the things that I was alarmed to hear is that the antibiotic usage, on average, for, by the time a child reaches 2, is they've been on 2 to 3 doses of
Mhm.
antibiotics, right? For a child, a young child, or an adult, when you take antibiotics, what is that doing to your gut microbiome? And why is it so important? Why should someone care or even maybe think twice before just taking a round of antibiotics?
Keep in mind that even the CDC estimated a number of years ago that about 50% of the antibiotic prescriptions are written for things that antibiotics can't help.
Why would they write a prescription for an antibiotic if an antibiotic can't help that particular illness?
It's a couple of things. Number one, it's consumer pressure, believe it or not, right? So
Mhm.
if you look at urgent care centers,
Yeah, I was
every
gonna
city
say
has
that.
tons of urgent care
Yeah.
centers, right? If a patient comes in and has a cold or a flu, and most of the time when you're ill, it's going to be a viral thing rather than a bacterial thing. So someone walks into an urgent care center and they're like, you know what? I feel like crap. I have fever, blah, blah, blah. The doctor examines them and the doctor knows that this is a viral thing. So then the recommendation is go home, rest, drink your fluids, that whole thing, right? The thing is, patients do not want to hear that.
Patient says, "I want a
Patients want
Z-Pack."
a pill.
Yeah.
Yeah, they
Yeah.
want a Z-Pack. They want a
Yeah.
pill because they're like, I can't take days off. I got this, I've got that, I've got that. I want to get better, so
Interesting.
give me something. The doctor's going, okay, if I don't give them something, they're not going to come back here anymore. They're going to go to the one down the street. Right. And
Right.
so that it's actually there's a competition for this. And
Huh.
so they go in the mind of the doctor, because they're not as educated on the microbiome, they go, well, okay, antibiotics are harmless.
Whatever.
I'll
Yeah.
just give them a Z-Pack and they'll be happy, right?
Yeah.
It's not going to help them, but I'll give it to them and they'll be happy. And then the patient takes the Z-Pack and, 3 days later they feel fine, but that's the normal course of the viral infection anyway, right? So then in their mind, they're thinking, oh, that Z-Pack is what did it, right? And next time they're putting the pressure. So that's a big area where pressure comes from. And believe it or not, it's bigger among parents with their kids.
That's interesting. So it is a little bit of consumer pressure on the doctors.
It
They're
is.
asking for it kind of by name.
Yep, they are, and this leads to a second problem, because they're getting so they might get a 10-day course of clindamycin, for example, right? And maybe the doctor goes, "All right, maybe there's a sinus issue here. I'll give you clindamycin for 10 days," and then the patient feels better in 3 or 4 days because it's a viral thing and it's cleared up, and then they just stop taking the antibiotic, right? So then they don't even complete the course, which then increases the risk for antibiotic resistance, which means we have to then use more antibiotics when we do get an antibiotic infection. So it becomes a vicious cycle. So it becomes really important for people to understand as well that a huge percentage of the illnesses that you'll face in your life, the infectious illnesses, will come from viruses. And if your doctor is saying it's likely a virus, just trust them, right? And then go home and do all the things you need to do, right? Take your probiotics, prebiotics, immune support, and all that. Rest, take the warm shower, warm baths, just do all the things that are good for the immune system rather than feeling like you need to pressure the doctor into an antibiotic script. And so here's what happens then when you take an antibiotic, right? On the first dose of the antibiotic, it knocks down about 90% of all the microbes in your gut, right? So 90%, it's a huge, decimation of the gut microbiome. And then the thing about microbes is you're never going to kill 100% of every cell, right? So it knocks on about 90%, somewhere around 9 to 10% of the total microbes are still there, and there's representatives of each strain still there. So now over the next 6 7 hours, they start coming back. The problem occurs is that they come back in different proportions that they were originally, right? So one of the things that controls what the microbiome looks like in the gut is the production of lactic acid, right? The gut, for the most part, should be more acidic than it is neutral or basic, right? And the reason for that is because fungus and other pathogens grow better in a neutral environment or a basic environment. So the good bacteria in your gut keep control of them by making acid and keeping the environment more acidic. So those are lactic acid producing bacteria. Now, you take the antibiotic, all the microbes get knocked down, good, bad, and otherwise, right? So now all the lactic acid production has been shut down for a moment. And as a result, the pH of the gut goes up. And who does better in that environment? The fungus, the pathogens, and all that. So they come back faster, right? And then the next dose knocks them all down again, changes the environment, they come back even faster. So it's opportunistic growth is what occurs. There are studies that show that there's a imprint or fingerprint of a dysfunctional microbiome based on an antibiotic course. And they can see that same fingerprint if no intervention is taken up to 2 years after stopping the antibiotic. Right.
Wow.
And here's the other crazy thing. Another study showed not only is that imprint present in the person taking the antibiotic, but it's also present in people that live in the same household
Yeah.
that
I
did
wanted
not
to get
take
to
the
this.
antibiotic.
When someone in your household is taking a course of antibiotics, it can impact, because of the change in their microbiome, other members of the house. Is that right?
That's absolutely right. So think about our little micro communities that we live in, right? Our homes, our workplaces, places where a lot of the same people are gathered a lot of times. We in those environments we create a microbiome cloud, if you will, because everybody is shedding microbes into this space and picking up microbes from each other. It's a very natural and normal thing, and in fact, it's really important for community building, community structures, and all that. But the downside of it is that if somebody is dysfunctional, they're going to be shedding dysfunctional microbes and impacting the microbiome of others in that space. And so, when you take a course of antibiotics, it goes beyond just having creating harm within yourself. It can create harm within others as well. And again, as a disclaimer, if your doctor says you need an antibiotic, take it by all means. But nonetheless, there is a responsibility to the community ecosystem, right? And this goes beyond antibiotics to me because, if you're living with somebody, let's say a roommate or a sibling or whatever, who really doesn't care about their health and they're just doing whatever, they're eating fast food every day, drinking too much, all of that stuff, you're trying to improve your health by taking all the steps and measures. They are impacting your results negatively. You're taking two steps forward, one step back, right? And so, one of the things I always describe to people is that microbiome health, and thereby immune health and metabolic health and all of that, that the microbiome touches, is a community responsibility. And the community starts in your home, right? So if you're using a product for a probiotic, a prebiotic, anything to improve your microbiome, everybody in the household should be using it.
There's some great research on this too. The dogs are actually good for your microbiome, right? And especially if you have kids
Very
and dogs
much.
around, dogs can be really good for your microbiomes.
So studies on dogs have shown that households with dogs have kids with fewer incidence rates of allergies, asthma, viral infections. In fact, in 2020, a study came out that showed that bringing a dog into your home actually can increase your longevity, not only by the emotional component, right? That companionship and increase in oxytocin and all that, which is that love hormone and bonding hormone, but it's also the improvements in the microbiome.
When it comes to kids, and maybe some things that people haven't heard, what would you say, or what are some of the things that you do with your kids? What are some of the best things that kids can do for their microbiomes? What should you allow them to do? What should you not allow them to do? Kind of just some good points I think for parents would be helpful.
One of the things I've always said, for example, is when my kids were of that age where they were eating their boogers, I let them eat their boogers, right? Boogers are like these amazing little vaccines that people are self-vaccinating with, so if you think about all of the innate, what we would call dirty behaviors of kids, right? They're all there for because they're so important. So you think about a baby. A human baby is a very interesting creature, right? It's a completely helpless creature,
Yes.
right? You think about other animals like a baby whale when it's born. The next day it swims like 800 miles.
Yeah.
A baby giraffe and every other animal can stand and walk the moment they're born. They can run from predators and so on. A baby human is virtually non-functional.
Yeah.
But the one thing they all have, every baby up to a certain age, is they sample the entire world around them with their mouth,
Hmm.
right? Everything, as you know, goes in the baby's mouth, right?
Yeah.
So whether it's a new toy you put in front of them or anything around, they put it in their mouth, including their own foot, their own hands,
Right.
and they soothe themselves by chewing on their own hands and feet. And that is a really important innate behavior that we have to pay attention to. Because imagine what's happening with our ancestral babies, right? They're born in the outside environment, or they're born in caves or huts. They're put in the dirt, they're put in the ground, and babies are sampling the environment around them with their mouth. And as it turns out, some studies have demonstrated that when you get exposure to environmental bacteria early on in those first 2 years of life, the exposure of the environmental bacteria with some of the innate microbes that you get from mom work together to develop that entire gulf, that gut associated lymphoid tissue that we talked about earlier, where upwards of 80% of all your immune system is, right? Your immune tissue is. So just the development of the immune system and the immune tissue, the structures of the immune tissue, are dependent on exposure to the environment. Let kids be dirty. Now, of course, if you're in the mall and there's thousands of people walking around with dirty shoes and they're rolling around on the floor in the mall, that's a different thing than allowing them to roll around outside and get dirty and get their dirt on them. And one of the things that I see this all the time happening, I'm in the playground with my kids and they're getting dirty and playing in the dirt, and then it's snack time, right? And then when the kid runs over to the mom and they're hungry, they want a snack, the first thing mom's doing is dousing their hands with Purell and all that, right? Because their hands are dirty because they've been touching the dirt and the playground equipment and all that. To me, no, that's the kind of exposure you actually need, right? Eating with those hands that have been in the dirt and so on is really important. When the kids are babies, starting with babies and then all the way till they're older, They bathe too often. They use antibacterial soaps, antibacterial body washes, all of these things that disrupt the skin microbiome of their kids. And it's a very important and impressionable time for their skin microbiome and the barrier function of the skin, right? As a result of that, we start to see lots of issues on eczema, psoriasis becoming a bit of an epidemic in children. And that's all related to their skin microbiome being too sterile and dysfunctional, right? So being in dirt, not showering every single day with all the antimicrobials and all that, that's all really important to develop their skin microbiome.
I do want to transition a little bit into, speaking about family and fertility. And one of the things that we're seeing, right, is that the numbers of infertility just continue to increase. One thing that really captivated me was this connection between the gut and hormones. And so I want to talk
Mhm.
about that. And this is important for men and for women.
Let's separate the hormones a little bit. So we have sex hormones, which are your steroid hormones, right? So that's your estrogen, progesterone, testosterone, and so on. And then you've got all these other metabolic hormones that are really important, things like GLP and PYY, CCK, and so on. Ghrelin, leptin, all of these satiety, hunger hormones, and all that. Most of those metabolic hormones, the non-sex hormones, are actually largely produced in the gut, right? So the gut is actually making them. The sex hormones is interesting, is that the signals for production can come from the gut, and there are certain requirements within the signaling, because most of the sex hormones are produced then in the sexual organs, right, in the ovaries and the gonads and so on. But then the ovaries and the gonads are taking signals from the gut through the brain in order to dictate production. On top of that, the recycling of those hormones are also done through the gut and the liver, right? Because sex hormones and hormones in general work in a pulsatile fashion, meaning they are released, they go and they bind their receptors. The binding of the receptors effectuates a biochemical cascade, but then the hormone needs to be degraded or changed or metabolized so they're not constantly triggering that same receptor, right? You want hormones to work in a cycle. So estrogen, for example, one of the ways in which the main way in which the body recycles estrogen is estrogen then gets sent to the liver. So the estrogen that your ovaries produce, and it cycles through the body, it binds receptors and all that. Then at a given time in your cycle, it goes to the liver. The liver conjugates it, right? So what that means is that the liver puts like a chemical cap on the estrogen so that it's no longer recognizable as estrogen, right? And then the liver dumps that capped off estrogen back into the gut. Now, normally what's supposed to happen is that then gets digested and excreted through the digestive tract, but some of it gets deconjugated by microbes in the gut. Those microbes are part of a constellation of bacteria called estrobolome. Right now, you want some of that to happen because that's part of how your body maintains adequate estrogen levels when your ovaries are not producing enough. If you have too much of the estrobolome, then you get a huge portion of the estrogen that's been designed for excretion getting reactivated and reabsorbed. And that causes the condition called estrogen dominance. And estrogen dominance is the most common hormone imbalance issue in women, right? It can cause all kinds of issues. Of course, it can cause metabolic issues, PCOS, potentially things like endometriosis, even breast cancer risk, and so on. So it's estimated that about 80% of hormone imbalance issues in women come from estrogen dominance. And one of the biggest drivers of that is too much estrobolome. And a lot of the bacteria within the estrobolome constellation are enteric or gram-negative dysfunctional bacteria.
You need to be detoxing your body every day, right? So there's three ways to
Mhm.
detox. It's you're pooping, you're peeing, or you're sweating, right? And those, if you're
Yeah.
not detoxing on a consistent basis, things like estrogen dominance can become more prevalent, because one thing you probably didn't know, if you're not having regular bowel movements and you're a woman, is that you might be having more estrogen be circulated in your body than is appropriate.
Well, and here's another tie to it, right? So if you have that dysfunctional microbiome, which means you are recycling too much of your estrogen, leading to estrogen dominance, that same type of dysfunctional microbiome also drives vaginal dysbiosis, There's a connection between your microbiome, the mucosa, the mucus layer that your microbes live in, and the vaginal mucosa. And then that can lead to an increased risk of things like bacterial vaginosis, UTIs, and so on. That has a direct implication on fertility because fertility is in part dictated by the health of your vaginal microbiome, and the health of your vaginal microbiome is dictated by the health of your gut microbiome. And so it all cascades into this snowballing effect.
Yeah, and I think just for men and for women, the other thing that's really important to discuss here, in relation to hormones, but in relation to the gut microbiome and everything else, is just everyone's favorite word, stress, right? And again, just kind of I think a preface to this, and something that I kind of like to say, whether it's in a personal conversation with a friend who's going through stuff, or whether it's in a public forum, is that getting stressed about stress doesn't help anyone, right? So there's a lot of information. We do want that. We need to share it. It's important to share it. But, one of the things that, I was sharing over the weekend with a group was that just being in nature, and we happened to be outside for this particular event, but just being in nature for 20 minutes, not that long, 20 minutes, there's some pretty cool research that shows that can lower your cortisol levels by up to 21%. So there's just very practical things we can do to lower our stress, to lower the cortisol levels. However, we have Kiran here, and I think it's important we talk about the very serious and negative implications of stress in the gut.
Part number one is that in your system, which is covered with microbes, right, in your gut, in your blood, in your brain, everywhere, there's microbes everywhere. There's always opportunistic microbes, right? And they're called opportunistic because they have some basic functionality which can be beneficial, but given the right opportunity, they can become or act pathogenic, right? But they only express these virulence factors or these toxins under the right opportunity. Now, many of these organisms have evolved to look for stress indicators in the host as the signal for them to express their toxicity and start proliferating more. Because what they've come to learn is that when your epinephrine, your norepinephrine, your cortisol is elevated and you're under stress, it suppresses your immune system, and that becomes their ideal opportunity, right? Because they're not very strong pathogens, but they can do well under that state. So every time you experience a bout or stress or two, it's like taking a little antibiotic because it's messing up your microbiome. The competitive pathogenic organisms are going, hey, this is our opportunity, let's go crazy. And then they start expressing their virulence factors, hurting the beneficial bacteria, making their numbers higher, right? The second part of it is that as they start to grow and increase their prevalence among the microbiome, it helps them to keep the host in a stress state, right? Because that's the environment that they do the best in. So then they start producing things like neurotransmitters, inflammatory cytokines that trigger the host's HPA axis, which is the hypothalamic pituitary adrenal axis, which activates the fight or flight response. And so it's in their interest to keep the host in a constant fight or flight response, which they do really, really well. And when you're in that fight or flight response, it grows more of the pathogens. More pathogens that grow, they keep you in fight or flight response longer, and it becomes a vicious cycle. And this is why stress just simply continues to increase, and people's tolerance rate for what triggers them reduces over time, right? You might have been somebody that was really laid back and easygoing, but then now at some point, the smaller triggers tend to put you into this fight or flight mode. And that's a very inflammatory mode. You're not turning on your parasympathetic system, which is the rest, digest, repair system. You're constantly in inflammatory fight or flight response, right? You can't digest food. You can't activate your immune system. You can't repair damage that is going on. So that's a very unhealthy state to be in for such a large part of the day that your average person is in.
One other thing I wanted to just cover with you and pick your brain on a little bit here is another aspect of the gut microbiome we haven't talked about yet, which is fiber. How should we think about fiber and the importance of it, and why should we be tracking our fiber like we track everything else that we take?
Now, why does fiber matter so much? Well, number one, because high diversity in your gut microbiome is directly associated with longevity and disease resilience, right? Including metabolic diseases like obesity, diabetes, dementia, Alzheimer's, and all of that. And fiber is really important to slow down bowel movements and allow for adequate digestion of the foods that you are eating. And that allows for increased assimilation of nutrients, being able to pull the nutrients in from the food that you're eating so the food doesn't pass through your system too fast. On top of that, the fiber feeds microbes and they produce compounds like urolithins and short chain fatty acids and all that that we cannot really get from food and we cannot make ourselves, but are critically important to our cellular and metabolic function, right? And then fiber also acts like what these GLP-1 drugs are doing. They're slowing down the metabolic the digestion process. They're increasing satiety signals so you don't overeat, and they control blood sugar levels, right? It reduces the postprandial, which is after meal glucose response. So they're blunting the glucose curve, which is really important. And the type of fiber that does that the best are the high viscosity fibers, right? The high viscosity fibers have this magical component of going into your gut, binding water that you drink, and then swelling in your gut as a viscous substance, right? That really slows down the bowel movement. It really slows down sugar uptake and blunts that postprandial curve. So everyone's hearing all this stuff about insulin response and that being a big issue with your chronic disease and health and all that. The thing that blunts that the best are high viscosity fibers, right? And it's really hard to get those high viscosity fibers into your system. You can't find them in foods easily. You can't supplement them at any given amount unless you have a product that does that.
We just put them into our product Feel Full, and for that exact reason. And yeah, I mean, it's I would say a kind of an uphill battle. I often would say that in an ideal state, the supplement whole category wouldn't exist, but here we are, and it's more important than ever. What are some of the pillars day to day that you would encourage everyone to really take a look at and maybe evaluate in their personal lives?
So I boil it down to 5 pillars that people have to pay attention to, right? Pillar number 1 is diet. Like we talked about, you want to improve your diet, clean it up, increase your fiber, get more fruits and vegetables, get more real food into your system. Number 2, stress management. We talked about the importance of that. Number 3, exercise. Combine your exercise with being outside is great. And then weightlifting. What people don't usually know is that contraction of your muscles against a force like a weight actually releases a set of chemicals called myokines that can actually go and heal and improve your gut and increase the gut microbiome diversity, right? And then number 4 is exposure. So reduce your exposure to chemicals that harm your microbiome, increase your exposure to beneficial microbes, including to other people. So getting together in person with people makes a huge difference, right? And then the last thing, and then within that exposure is also kind of sleep and repair and adequate time. And then the last thing is supplements, right? Supplements can be a huge help when added to some of these other choices to really boost and accelerate the outcome. So do one thing in each of those 5 pillars each day, and you'll absolutely change your life and your outcomes. And it's all within your control.
That's exactly right. And we can't optimize everything that's without our control or with outside of our control, but these things are within our control, which means these are the
Yep.
things we can optimize and we should be. So thank you so much. It's awesome to chat with you. I knew this going into it, and I can say it now. Definitely, this is going to help a lot of people. And so I really
My
appreciate
pleasure.
you spending the time and being the profound communicator that you are, because this is exactly what we need to be doing more of, and it's what's going to turn the dial here and hopefully help millions of people get healthier and healthier each day. So thank you so much.
Thank you for having me.